Class is now in session. This is Weather U with Gabrielle Espinosa.
Did you know lightning strikes over 1 million times a year here in the state of Louisiana? Where does Lake Charles fall in all of that? Well, we rank as one of, I would say, the top 20 cities in the nation for most lightning-prone cities. Now, Florida, of course, is going to be the top state and have most of those top cities as well. Those lightning bolts here on the map are going to represent where lightning strikes the most, and the most concentrated area is going to be into the state of Florida. That continues along the Gulf Coast through the Panhandle into portions of Alabama and Mississippi, and then all along our coast and just a little bit down into Texas. So I would say Lake Charles ranks pretty high up there in those most lightning-prone cities. So it's going to be important that we understand how lightning forms. So to figure that out, we're going to start with one of these guys behind me, a Cumulonimbus Cloud. Now that just means it's a rain-producing cloud, and the depth of the cloud has to be to a great enough extent that we can see this process that I'm about to explain to you happen. So we're going to take a look inside of this cloud, get down to a molecular level. We're going to start with a raindrop. It's going to be at the base of the cloud. It's not frozen yet, but as we move up in the atmosphere, we'll see that change. We're going to start with these positive and negative particles. The positive ones are going to be the plus signs in the red. Those are going to be the protons, and then the blue ones, the negative signs, are the electrons. Now, as we move up in the atmosphere and this raindrop starts to freeze, we're going to see the particles align themselves in a certain way. It's kind of resembling an egg. So the positive particles are going to represent that eggshell, forming a casing around these negative electrons in the middle, kind of like the yolk. As we zoom out, we're going to see that these positive particles are going to congregate towards the top of the cloud. So we'll have a lot of positive particles at the top and a lot of negative particles at the bottom. That makes the atmosphere unbalanced, and the atmosphere doesn't like that. So we're going to see this try to change. So how does that happen? We're going to see these negative electrons reach their way up towards the positive protons, and they'll reach their way down, and we'll see lightning strike. Now what we see is going to be the return stroke. There's a bunch of stuff that goes on initially that the eye cannot see. We're going to see that return flash that we just saw happen between these particles to try and balance themselves back out. Now, it doesn't just happen inside the cloud. We can see cloud-to-ground lightning as well, where we see a concentration of positive particles right here along the ground. That same process is going to happen. We're going to see those positive particles reach up towards those negative particles. The negative particles reach on down, forming those step leaders. Kind of looks like a step ladder, and then we'll see that return stroke happen, and that's when we see that flash of lightning. Now, it doesn't just happen inside the cloud or from the cloud to the ground. We can also see cloud-to-cloud lightning as well, trying to balance the atmosphere out, because we're going to see the same setup over here with those negative particles concentrated along the bottom and the positive particles concentrated at the top. And there we go. We're going to see that flash of lightning as the atmosphere tries to balance itself. Now, how does thunder relate into all of this? Well, as the lightning strikes, the air around is going to expand rapidly. It's going to heat up, it's going to expand, and then we're going to hear that thunder, that loud rumble of thunder after the lightning strikes. Now, it's just not because light travels faster than sound. It's because it's a process that happens after the lightning strikes. So lightning, hotter than the surface of the sun, strikes across the sky. That's going to heat up the particles around the lightning flash. That's going to expand rapidly, and that's where we hear the thunder from. Now, lightning can also be dangerous. Stay tuned for my next video as I detail some lightning safety.